Welcome back to Coding at Home. Today I'm introducing Cody and Roby, starting from Ada and Charles, the two mathematicians that we met last time. Charles was not only a mathematician but also an inventor, and he invented the analytical engine, a universal computer able to make any kind of computation, provided that someone else, in particular Ada in this case, gave to the machine the instructions in order to guide the machine to make the computation. This is not just important for the analytical engine by itself, but also because it was the first time in history that someone invented a programmable machine, a machine that required a programmer and a computer program in order to be able to do something just because it was able to make everything, to do everything. And in order to decide what to do, it requires instructions, just because it is it is able to do so many different things. Now, the idea was that of having an ideal performer. An ideal performer is a performer which does exactly what we tell it to do. And this also means that an ideal performer requires someone else with a brain to decide what it has to do and to provide instructions. And this kind of separation of roles was very, very important because it led to the computer science and the current separation of roles between hardware and software, and between the ideal performers, which are nowadays computers and robots, and programmers, who are the ones that write the programs in order to make computers and robots able to do something useful for us. Okay. Today we have this small robot that we built last time that will play the role of the ideal performer, and we need to build a suitable instruction set in order to be able to provide instructions to guide the robot on the checkerboard board. And this is not a universal computer, but it is universal enough to be able to reach any box on the checkerboard board, provided that our instruction set is suitable to this purpose. So let's focus on the instruction set. We say goodbye to Ada and Charles. And in order to introduce the instruction set that we are going to use, let me restart from the instruction set that we already used. This one with footprints was made just by three color footprints: the yellow one meaning turn left, the gray one meaning go straight, and the red one meaning turn right. The idea of this instruction set was to place tiles directly on the checkerboard board, and in particular, if I place the tiles in this way, this would have led our robot to go straight, turn right, turn left, and arrive here. Okay? But in this case, what happened was that at each step, the robot found the instruction directly along the path. And it had to follow the path. And this means that once it executed the instruction associated with the color and the footprint represented on the tile it stepped into, it had to move forward to find another instruction. This is very, very important because robots and computers always have to move to the next instruction in order to keep executing the program. And if the instructions are directly placed along the path, this means that going from a box to the next one is something which is implicit, inherent. It has always to be done regardless of the instructions that was executed. So this is the reason why these three instructions don't tell the robot to move, but just to turn. So the gray one means don't turn. The red one means turn right, and the yellow one means turn left. While the movement from a tile to the next one is always made regardless of the color of the tile. Okay? And the same happened with this other instruction set made just of colors, because we could use them exactly in the same way. So by going straight, so basically keeping our direction and then moving to the next one, turning right and moving to the next one, turning left and moving to the next one, and so on. Okay, so if I place these three instructions of the instruction set here just to make them visible together with their colored counterparts, I use them to introduce the new instruction set, which is no longer placed along the path, but instead represented as these cards that can be just shown to the robot in order to provide instructions. So this card here, the yellow one with this arrow to the left, means turn left. The red one with the arrow to the right means turn right. And then we need a third instruction, which is no longer a gray one, but it is a green one. Do you know why? Because in this case, having the instructions not directly placed on the path, our robot does not move by itself. It has to wait for an instruction also to move forward, to go ahead. And this is what this third instruction, the green one, tells to the robot. Okay? So now that we have the instruction set, I have just to tell you something more about the labels that you find on the checkered board, around the checkered board, and these, you see, these words that you can probably read on some of the boxes. So this is north, this is east, this is west, and this is south, exactly as if this was a map. On the other hand, here we have labels A, B, C, D, E, which denote the columns of our checkered board. And we have also labels denoting the rows, which are numbers 1, 2, 3, 4, 5. This allowed me to tell you a position just by providing what are called coordinates. So the label of a column and the label of a row. If I say B2, this means, Anna, that the robot have to be placed where? In the checkered board? Here. Great. So if I say, for instance, D4, you see, without pointing to the box, just by specifying the coordinates, Anna can place the robot in my place. Okay? But why I can also mention north, east, west, and south? Because by just saying where to place the robot, I'm not specifying whether the robot has to be placed this way, this way, this way, or this way. And this is very important because this is the starting point, for instance, of a robot. And if I tell the robot to move forward, then starting from here, the robot will move here. Starting from here, it will go to another box. So also knowing to which side the robot is oriented is very important. So I can tell Anna to place, for instance, the robot in D1 facing east. Okay, you see, this time if I tell her to place the robot in C2 facing south, you see, now she knows exactly how to place the robot, not just in which box, but also on which side, in order to having a unique starting point for executing the instructions. Okay, now this is Roby, which is our robot. But who is Cody? Cody is the coder. So is the one providing instruction. So since our instructions are the cards that I mentioned, the red ones, the yellow ones, and the green ones, I will have the cards in my hands and I will play the role of Cody, the coder, the programmer, while Anna will play the role of Roby just by moving the robot on the checkered board, okay? And in order to provide instructions, I have to show the instructions. So for instance, if I use this one, Anna, please move accordingly, okay? And then this one, okay? And this one. Okay, you see that now Anna is moving her robot to the next box only if I tell her to do so by using this green instruction. And this also means that I could tell her to turn left and possibly to turn left again. Notice that this is something that was not admitted with the previous instruction sets, because if the instructions were placed directly along the path, each instruction had to be executed only once per box. So while stepping on this box and finding, for instance, a yellow footprint, the robot had to turn left and then move to the next box without staying on the same, while I could keep telling Anna to make her robot turn left as many times as I want, and in this case the robot would keep turning and turning and turning. Okay, right now we used these cards just to guide the robot in real time. What do I mean by saying in real time? I'm saying that as I place a card, Anna makes the corresponding move. Please. Okay. Programming is something quite different, because when you have to write program, you have to write it beforehand and then make it executable for a robot or for a computer. So in this case, this means that if I know, for instance, that the robot is here and I want to reach position E2 facing east, I have to write a program, and the program that I could write that I can write could be this one. So turn left, I have to think if left is the proper instruction to be used. Then move forward, forward again. Okay? And now I can tell Anna to execute this program instead of executing instruction by instruction, step by step. Okay? You see, so right now she executed properly this program and the program was correct. But now let's start again from here with the same target position, which was this one facing east. So in this case I could have made another program and see the effect. Anna, could you please execute this one? Okay, is it correct?
No.
Why?
Because I have to be facing east and now I'm facing south.
Okay, good point. So this means that by writing this program, I made a mistake. So making mistakes while programming is very, very common. And this means that it is very important to test your program before being sure that it is correct. And in this case, in order to test the program, I have to ask my ideal performer, Anna and Roby in this case, to test it for me. And only by seeing the effect of the execution, I can double check that the program that I wrote reaches the goal. Okay? This is called debugging. Debugging means getting rid of bugs. So finding and correcting the errors. So in this case, I made a programming error, and in order to correct it, I have to turn left here. Okay? So now we can easily check that it is correct just by executing this last instruction. But in general, we have to re-execute it from scratch because the error could be much harder to find and correct than the one that I made this time. Okay? So could you please re-execute it? Okay, great. Now we can make a first game with this instrument, which is called CodyRoby. Okay, so the combination of these cards and any kind of piece to be used as a robot to be moved on the checkerboard board is called CodyRoby. And I would like to point out that these cards can be combined as the tiles of a puzzle, as you can see, thanks to this small tip here that fits into the next card. So this means that in order to provide not just an instruction but an entire program, I have to concatenate instruction in this way, and this becomes a sequence of instructions to be executed one at a time, starting from left to right. Okay, this is very important. And right now I would like to make a first game with Anna, which consists of taking the cards that we like from this deck, and by building a program for our robot, and we can try to build a program together, but being careful because we have not to make a move which brings the robot out of the checkered board. Okay, so I can add an instruction here, and you have to add another one, and we can keep making our program as long as we can, but without moving our robot, as if we were programmers. And this is quite hard because we have to figure out where the robot is, or where the robot would be if the robot was executing our instructions. Because if we don't imagine where the robot is according to the instructions already on the table, we cannot decide which instruction to add, and we risk to bring it out of the checkered board and lose the game. So we lose the game if we make the wrong move and the other player notice it. Okay? So both players have to be very careful, both to make their own moves and to double check the other player's move. Okay, so right now, do this. Okay. Okay. Let me keep programming on another row. Okay. I'll do this. Now she has cancelled my move basically, and I insist. Okay. Okay, and now just.
Okay, that's a mistake.
Okay, that's a mistake, and she noticed it. So let's double check if. Could you please make the moves while I.
Yes.
Okay. Okay.
Left, straight, straight, right, straight, right, right, left, right, straight, and straight.
Okay, so the last one was my move, and it was the wrong one just because at this point we were here. Then I decided to go ahead again, and by going ahead, I caused the robot to exit the checkered board. So this means that Anna won this game. Okay? So that's it for today. Thank you for your attention.
Thank
and
you.
Goodbye.
Bye.
Bye bye.